Hey everyone, welcome to the second video for section 3.6 in the book. So in this video, we're just going to be doing an example of how to solve an equation using variation of parameters. So just going to set up an example, we're going to do the whole thing, start to finish, work everything out, and so hopefully this will make it more clear how this method works and how you can solve these problems if you're given them to do on worksheets or on an exam or things like that. All right, let's go ahead and jump right into the example. So the example here we want to solve is the following. Find the general solution of y double prime plus 4y prime plus 4y equals t to the minus 2 e to the minus 2t. So where do we start? We got to start by finding the solution to the homogeneous equation. So homogeneous equation, we have a characteristic r squared plus 4r plus 4 equals 0, which is r plus 2 quantity squared, which means the general solution for homogeneous is yc equals c1 e to the minus 2t plus c2t e to the minus 2t because it's a repeated root. So there's our general solution to the homogeneous case. Now I want to look at trying to find the solution to the non-homogeneous case using the variation of parameters. So what do we guess? So variation of parameters method, I want to guess y of t equals u1 of t times y1, which is e to the minus 2t, plus u2 of t times y2, which is t e to the minus 2t. And now how do we solve this out? We take two derivatives, we plug everything into our equation, and we try to solve things out to make it work. So let's see what we get. Let's take a first derivative. Y prime of t is negative 2 u1 of t e to the minus 2t. I'm going to write these terms in the same order I did when going through the solution method in the last video, so we'll see which terms end up going to 0. Plus a u2 of t e to the minus 2t minus 2 u2 of t e to the minus 2t. And that part there is from product rule hitting on this t e to the minus 2t term. And then plus a u1 prime of t e to the minus 2t plus a u2 prime of t e to the minus 2t times t. And now the assumption we're making in variation of parameters is that this guy here assumed to be 0, which means the only terms I have left in my first derivative are these top three on the first line here. So now let's go ahead and take a second derivative. Y double prime of t equals what? So the first term, I'm going to see a minus 2 u1 prime of t e to the minus 2t plus a 4 u1 of t e to the minus 2t plus a u2 prime of t e to the minus 2t minus 2 u2 of t e to the minus 2t. And the last term for product rule, I'm going to get a minus 2 u2 prime of t e to the minus 2t minus 2 u2 of t e to the minus 2t plus 4 u2 of t e to the minus 2t. Okay, there's my second derivative. So now I want to plug it into my equation, which is y double prime plus 4y prime plus 4y, and see what happens. So y double prime plus 4y prime plus 4y equals y double prime plus 4 times y prime, and then plus 4y, and that's my whole equation. Yes, it's a lot, it's kind of nasty, but now let's do all the grouping that we had before. So let's pick out the u1 prime, the u2 prime, the u1, and the u2. So I get u1 prime is just on the first term, again, as it was before. So minus 2 u1 prime of t e to the minus 2t plus the u2 prime only shows up twice. It shows up here and it shows up here, like that. Then I see u1 of t times 4 e to the minus 2t from this term here. So I've dealt with this term, and this term so far. minus 8 e to the minus 2t from this guy here, and a plus 4 e to the minus 2t from that guy here, plus whatever comes out of u2. And I'm just going to copy it down here. You can figure out what it is, but I'll just copy it down here and then we'll look at it again. And after all that messy algebra, this is what we get. So I just grouped all the terms together by the way they were set up. And now if we look at the terms that show up in these expressions, this term goes to 0, and this whole thing goes to 0 because both the t to the 2t's and the e to the negative 2t's just vanish on their own. So I end up with negative 2 u1 prime e to the minus 2t plus u2 prime of t e to the minus 2t minus 2t e to the minus 2t equals g of t. And g of t here was t to the minus 2 e to the minus 2t. Now what I'm going to do right now to make things easier is I'm going to cancel an e to the minus 2t from every term in this equation because I can do that because e to the minus 2t is never 0. So the remaining equation is minus 2 u1 prime plus u2 prime of t times 1 minus 2t equals t to the minus 2. And then we had our other assumption before, which I'm going to scroll back up to so we can see it, was that this guy here was 0. So this equals 0 as our second equation. And again, I'm going to cancel an e to the 2t from every, e to the minus 2t from every term. So the equation I get from there is u1 prime of t plus t u2 prime of t equals 0. All right, so now we just have left to is solve the system of equations. We have the system of equations here we want to solve. So what am I going to do? Well, I'm going to multiply top and bottom, but the second equation, sorry, multiply the second. So what am I going to do? I'm going to multiply the second equation by 2. 2 times 0 is 0, and then add them together. If I add the equations together, I will get 0 plus, now the 2t's are going to cancel, so I'm just going to get just a u2 prime of t here, equals t to the minus 2. Good. So this is my one equation. And then if I plug that into the second equation down here, I see that u1 prime of t is going to be negative t u2 prime of t, which is now going to be negative t to the minus 1. So now I have solved for u1 prime and u2 prime. Now I can integrate them both to solve for u1 and u2. So these two tell me that now my u1 of t is the negative integral of t to the minus 1 dt, which is going to be negative log of t plus a constant. And u2 of t is the integral of t to the minus 2 dt, which is negative 1 over t plus a constant. But that's not the answer. This gives you my u1 and u2. My solution to the non-homogeneous equation is u1 y1 plus u2 y2. And we'll notice again that, like reduction of order, we can get rid of these constants. Why? Because if I put the constants in there, I'm just getting more copies of y1 and y2, which I'm going to throw into my homogeneous case anyway. So what I get from my solution to the non-homogeneous problem is this. So y of t is u1 y1 plus u2 y2, which is negative log of t times e to the negative 2t plus a negative 1 over t times t e to the minus 2t. These t's cancel and I get an e to the minus 2t here. But this is just y1, so I can just kind of forget about it because it solves the homogeneous problem. So my solution to the non-homogeneous equation is log of t e to the minus 2t, which then means what is my general solution? This then means my general solution is y of t equals c1 e to the minus 2t, there's my y1, plus c2 t e to the minus 2t, there's my y2, and then minus log of t e to the minus 2t, which is my solution to the non-homogeneous part of the problem. So that is a full worked out problem for variation of parameters. Now, could you have made this shorter? Probably. The book gives you the equations for the shortcut to get you right to the system of equations, but I wanted to see all the details worked out once to make sure you understood what was going on with all that. Now, if you were to just use that shortcut, the system of equations you're trying to solve is this one. And if you plug in our U1 or Y1 and Y2 from before in G, you'll get the exact system equation that we solved for via all this method. Sometimes this is helpful to jump to the conclusion like this. Sometimes it's easier just to work it out on your own and not worry about did you memorize the system equations properly. In a case like this, even though this is a long problem, it really wasn't that complicated. You just had to follow through all the calculations and make sure you did all the steps correctly. All right, so that's it for this video. There is a full worked out problem doing variation of parameters. Hopefully this now makes a little bit more sense, and if not, we can talk about it tomorrow in class. Thanks a lot for watching, and I'll see you in the next one.